Hello, hi everyone. Welcome to the student brand. This is your Siva sir. So now we are discussing about human eye and colorful world. Human eye and colorful world. So let's start. Let's start. Human eye is the most sensible and sensitive organ in our body. Human eye is the most sensitive and sensible organ in our body. Okay. So first we'll discuss about human eye parts and function. So we will discuss about human eye first, about parts and their functions. After that, we will discuss about refractive defects. So before that, near point, far point, power of accommodation. So after all those things, so we will discuss about refractive defects, myopia, hypermetropia, presbyopia. So after that, we will discuss about light ray passes, colorful phenomena, light ray passes through the prism, how it will disperse, and recombination of spectrum of white light, rainbow formation. After that, so we will discuss about atmospheric refraction and scattering of light. After that, Tyndall effect. So these all points we'll discuss in the human eye. Human is the most sensible and sensitive organ. So through our eyes, if you close your eyes, you can't able to see anything. Once you open your eyes only, you can able to see everything, right? Yes. So this is class 4. So I hope class 1 about light reflection problems. Next one, class 3 about refraction. This is a class 4 about human eye. This is a class 4. Okay, so class 4. Class 4. So this is a class 4. Those who are there. So you can check once class 1, class 2, it is available. Okay, so it is there in the playlist. So you can check once. Okay. So I hope it is very clear, right? Yes. So let's start. Human eye parts and function. Human eye parts and function. So drawing human eye, it is very easy, very simple. Drawing of human eye, it is very easy, very simple. I will draw and show. Just check once. Here I am drawing. Okay, so human eye diagram. This is a human eye diagram. Understood? So I am taking this convex lens. Convex lens. Okay, so cornea, cornea, and aqueous humor, aqueous humor, aqueous humor. And next one is retina. So this is iris, 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 and this one also iris. So these are ciliary muscles, ciliary muscles. Okay, and here it is the pupil. Here is the pupil, and this one is the eye lens. Eye lens is a crystalline lens. Eye lens is a crystalline lens. Next one, this is the vitreous humor. Vitreous humor. Vitreous humor. And this one is the retina. Retina. And optic nerve. Optic nerve. Optic nerve. Yeah. So I asked Ma. So as of now, I didn't get reply from Remani. So I will ask again once again. So okay, definitely I'll ask. So optic nerve, retina, vitreous humor, human eye. Human eye. Okay. So human eye. So first one is the cornea. Cornea is a frontal layer. Okay, ma, sure, definitely. So cornea is the frontal layer, protective layer. Most of the refraction takes place at cornea. Okay, so here you can observe. This is the cornea. Cornea is a frontal layer, protective layer of the eye. Most of the refraction takes place at cornea. And coming to the aqueous humor is a jelly type liquid present between cornea and eye lens. So this is the aqueous humor. Aqueous humor is a jelly type liquid present between cornea and eye lens. So next one, iris. This one and this one is iris. Iris is a dark muscular diaphragm. Iris is a dark muscular diaphragm which controls the size of the pupil. People will control and regulate the amount of light entering into the eye. People will control and regulate the amount of light entering into the eye. Iris is a, so already mentioned, so it is a dark muscular diaphragm which controls size of the pupil. People will control and regulate the amount of light entering into the eye. And coming to the ciliary muscles, so normally if you want to see nearby object, okay, so in mobiles we can able to zoom in, zoom out according to the distance of the object, so we will do it. But in real life, so if you want to see nearby object, immediately we can able to see. At the same time, if you want to see far distance object also, we can able to see. Okay, so without any gap. So immediately we can able to see the near distance as well as far distance. So what exactly is happening? Ciliary muscles. Here you can see ciliary muscles are the nerves. So ciliary muscles which are holding the islands, Okay. So it adjusts the curvature of the islands. Ciliary muscles will adjust the curvature of the islands so that islands can adjust its focal length eye lens can adjust its focal length and so that whenever light rays falls on it, converge the light rays and make it falls at retina. Coming to the eye lens is a converging lens. Okay, so whenever light rays falls on it, converge the light rays and make it falls at retina. And coming to the vitreous shimmer is a jelly type liquid present between. So it's like a water fluid. Okay, so water fluid. So it is present between eye lens and retina. This entire portion is filled with this vitreous shimmer. So at retina, so it is a light sensitive screen. Retina is a light sensitive screen. Okay, so there are two types of rods and cones are there. There are two types of rods and cones are there. Rod sense the intensity of the light, cone sense the color of the light. So first one is rod sense the intensity of the light, cone sense the color of the light. Okay, rod sense the intensity of the light, cone sense the color of the light. Okay, so if more rods are there, even we can able to see during night time also. You can observe how well can able to see during night time also because they have more rods. Okay, so that is one point. And what are the images forming at retina? That is real and inverted image. That 2D image that will be converted in the form of electrical signal that will reach to the brain through optic nerve. So what are the images forming that will be converted into electrical signal? So that will reach to the brain through optic nerve. So this is the optic nerve. Understood? So retina. And coming to the one more that is. So what type of image will form at retina? Real and inverted image. Real and inverted image is forming at retina. Real and inverted image is forming at retina. Understood? So that will be converted the electrical signal reach to the brain. Brain will add the additional information so that we can able to understand. So water is filled in the glass, how much depth it is filled, how much height is it filled, so how far it is, everything. So the 3D information will be given by the brain. Okay na? So brain will add that additional information so that we can able to see the object. Understood? So that's enough. On coming to the optic nerve through these nerves, the information will reach to the brain. Understood? Right. Next one. So we will discuss about near point and far point. So what is a near point and what is far point? So the minimum distance up to which a person can able to see clearly without any strain, that is called near point. The minimum distance up to which the minimum distance up to which a person can able to see clearly without any strain is called a near point. Near point is nothing but the minimum distance. That is 25 centimeter for the normal healthy person. For coming to the far point, the maximum distance up to which a person can able to see clearly, the maximum distance up to which a person can able to see clearly the point. Okay, that is a maximum point. So that is infinity. Okay, so infinity is the maximum. That is nothing but far point. So range of vision is 25 centimeter to up to infinity. So near point is 25 centimeter. Near point is 25 centimeter. Far point is infinity. Okay, normally near point is 25, far point is infinity. Range of vision is 25 to infinity. So range of vision. Understood or not? So I hope it is very clear. So then next one is so while we are aging, so what happens? So ciliary muscles can't adjust properly. At the same time, eye lens cannot refract light properly. So those light rays will not meet at retina. So by that some defects will arise. Those are called refractive defects. Okay, while we are aging, ciliary muscles cannot adjust its Okay, so cannot adjust. Okay, cannot okay, flexible, so it is not that much flexible. Eye lens cannot adjust its focal length, so and it does not refract properly. By that the light rays will not meet at retina. Okay, so because of all the things, few so defects will arise. Those are called refractive defects. One is myopia, hypermetropia, presbyopia. Myopia, hypermetropia, presbyopia. Coming to myopia, so what is myopia? So I'm taking this one. So myopia is nothing but the person can able to see clearly the near point, he can't able to see the far point. Okay, the person can able to see clearly near point, he can't able to see the far point. So near point is 25 centimeter, far point infinity. But so the person who has myopia can see between 25 to infinity. Okay, so normally the person can able to see clearly near point, he can't see the far point. But so between 25 to infinity he can see. Between 25 to infinity, between that point he can see. That is the far point of myopic eye. Far point of myopic eye. And if the light rays are coming from infinity, where those light rays will meet, we will see. And how to correct this defect. So by using what lens we will use, which lens we use to correct this defect? Concave lens. We are using concave lens to correct the defect of myopia. We are using what lens? Concave lens to correct the defect of myopia. Understood or not? So let's start. So I'll draw the diagram. Check once here. So I'm drawing diagram. So this is the far point of myopic eye. Far point of myopic eye. So those are far point of myopic eye. Far point of myopic eye. Coming to myopic eye. Myopic eye. So if the light rays are coming from infinity, where those light rays will meet, we will see. If light rays are coming from infinity, where those light rays will meet. So I'll check once. So here you can see. Myopic eye. Light rays are coming from infinity. Myopic eye. And coming to the correction of myopia. Correction of myopia. Is it curved? It's okay. Yeah, I'll take marathon. So now what I'm doing, so I'm taking like a classes. So I'm designing. So this is the fourth class. So this is the fourth class. So I'm preparing a classes. Okay. So even though I'm taking live classes, so I'm preparing classes like all the chapters, all the topics. So it's okay, fine, no problem. So we have one more chance, right? Don't worry about it. So we have one more chance. No need to worry about it. You can do it. So I'm preparing classes. Okay, I'm preparing classes like class 1, class 2. In class 1, so light reflection, light reflection part I explained. So class 2 related to reflection part, problems I explained. And class 3 refraction part, and this is now human eye. So class 4. So I'm already uploading target 25, target physics 25 by 25. So in that playlist, target. Okay, in that playlist. So hope for the best. Hope for the best. Don't worry about it. Hope for the best. Okay. So believe, confident. Okay. So that's enough. Do your work. Do your work. Definitely everything will comes into positive way. So be positive, think positive, be confident. So you should not lose hope. Okay. We should not lose hope. That's enough. Okay. So you should not lose hope. So always be strong, be confident, and focus on your preparation, focus on your exam. That's enough, nothing else. Okay. So I am doing. So you have to do it. So do your work. So I'm preparing classes. Okay, I'm preparing classes. So I'm preparing classes. Those will be uploaded in the target physics 25 by 25. In that I'm uploading. Okay, so like even like a we can say what we can say shorts. Like a shorts also I'm uploading. Just check once. Just check once. Shorts also like important questions. So which I am not able to cover in the class. I'm uploading in that. You can check once, right? Okay, done. So myopic eye. Next one. So which lens we are using? Concave lens. We are using concave lens to correct the defect. The what lens? Concave lens. This is a concave lens. Okay, so this is N and this is F and here also F and this one is N. Okay, light rays are coming from infinity. Light rays are coming from infinity. So you can see these light rays after. Actually, you have to show the diverging nature. You have to show the diverging nature like this. And here also you have to show the diverging nature like this. And here also you have to show the diverging nature. Okay. So those dotted lines should meet here at far point. Those dotted lines should meet this far point. So this is the correction of myopia. Correction of myopia. Correction of myopia. Correction of myopia. Understood or not? So point number 1. So you can check here in this case. This is a far point of myopic eye. Far point of myopic eye. So as I mentioned, if the light rays are coming from, so I mentioned this concept. So follow this concept. Follow this concept here. You can take. Oh, this is the 25 centimeter, and this one is infinity. So infinity. So we can take infinity. And between 25 to infinity, you can see that is the far point of that F is nothing but far point of myopic eye. This is the myopic eye, and this is the correction of myopic eye. Correction of myopia. So check once here. Check once. We are using concave lens. Concave lens we are using near point, far point, near point, far point. And if you observe this second diagram, you'll get to know. If you observe the second diagram, you will get to know that is. So you can observe. If you observe this second diagram, you will get to know causes of myopia. Okay. So excessive curvature of the eye lens, that is nothing but short focal length, and elongation of the eyeball. So eyeball is too long, focal length is too small. Eyeball. So elongation of eyeball is too long, focal length is too small. Focal length is too small. So these are the causes. So they will ask for 2 marks. Causes. So very very important. Elongation of eyeball and short focal length. And excessive curvature of the eye lens also. Excessive curvature of the eye lens is nothing but so more for curvature eye lens, power will be more, focal length is less. So focal length is less, at the same time eyeball is too long. So these are the causes. Understood or not? I hope it is very clear. So this is about myopia. So far point of myopic eye, correction of myopia. So now we'll discuss about hypermetropia. So myopia song. So very very important. So remember, just for remembering sake, I am doing all these points. Remembering sake. Okay. So keep in mind all those points. Myopia, myopia, myopia. Myopia, myopia, myopia. Near distance we can see. Far distance we can see. Myopia, myopia, myopia. For that correction we are using. Bro, what bro? For that correction we are using concave lens, concave lens, concave lens. So near point we can see, far point we can see. For that correction we are using concave lens. So let's start this about myopia. Hypermetropia, 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 hypermetropia. For a distance we can see, near distance we can see. Hypermetropia, 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 hypermetropia. Okay, so hypermetropia. So we can see here human eye and colourful world. Human eye and colourful world. Colourful world. Okay, so if you are taking this the person, okay, this the person, so this is 25 and this one is in infinity. The person can able to see far point, infinity can see, but he can't see 25, but between 25 to infinity he can see. Between 25 to infinity you can see, that is the near point of hypermetropic eye. So now we'll draw the near point of hypermetropic eye. So if the light rays are coming from N dash, those light rays will meet at retina. Okay. If the light rays are coming from N dash, so you can see here, those light rays will meet at retina. This is the near point of hypermetropic eye. Here, N is the normal near point. N is 25 centimeter. N dash is the near point of hypermetropic eye. Near point of hypermetropic eye. Near point of hypermetropic eye. Okay, so this is the near point of hypermetropic eye. Near point of hypermetropic eye. Hypermetropic eye. Okay, so now if the light rays are coming from 25, where those light rays will meet, we'll see. If the light rays are coming from 25, okay, where those light rays will meet, we'll see. If the light rays are coming from N, those light rays will meet at retina. So this is the near point. So this is a hypermetropic eye. Hypermetropic eye. Hypermetropic eye. Metropic eye. And if coming to the correction, so this is the correction diagram. Correction diagram, hypermetropic eye. Ooh. Okay. So these all points, you can observe all these points, all these, okay, and you have to place. So which lens we are using? Convex lens. What lens we are using? Convex lens. Convex lens. So I have to take those light rays to the edge. So the extended light rays will meet at N dash. Okay. So these extended light rays. Okay, so here you can observe. So what is this one? Correction of hypermetropic eye. Correction of hypermetropic eye. Observe the diagrams. You can check with any textbook. Correction of, in textbook this middle line is, okay, so just check once. This middle line is not there, but any two lines are. So correction of hypermetropic eye. Hypermetropic eye. Correction of hypermetropic eye. So check once. Check all these three diagrams. I hope it is very clear. So if you have any doubts, let me know. So concept is very important. You have to understand the concept. First, near point of hypermetropic eye. So this is the hypermetropic eye, and coming to this one, correction of hypermetropic eye. So here light rays are coming from N dash. That's the near point of hypermetropic eye, and coming to here, light rays are coming from M. The light rays will meet beyond retina, and here you can observe light rays are meeting at retina by using convex lens. So hypermetropia, convex lens. Hypermetropia, hypermetropia, hypermetropia. Okay, done. So now we'll discuss about presbyopia, presbyopia, cataract, astigmatism. So now you can see presbyopia. Presbyopia is nothing but the person can't able to see near distance as well as far distance. The person can't able to see near distance as well as far distance object. For the correction of presbyopia, we are using bifocal lens. Okay, here upper portion is concave lens, lower portion is convex lens. Upper portion is concave lens, lower portion is convex lens. Okay, so that is a bifocal lens. And coming to the cataract, so a milky and cloudy will form on our eye lens. So it can be corrected by using cataract surgery, that is laser surgery only. After that, we will go to the astigmatism. What is astigmatism? Person can't able to see the difference between horizontal lines and vertical lines. He can't able to identify. Okay, so to you by using suitable cylindrical lens, we can correct this defect. That is astigmatism. Okay, so next one, light passes through the prism. So how it refract, we'll see. So I'm taking this one. So this is the prism. Light ray is passing like this. So here you can observe it's split into 7 colors. 1, 2, 3, 4, 5, 6, 7. Okay, so splitting of white light into 7 colors is known as dispersion. Splitting of white light into 7 colors is known as dispersion. Those 7 colors will form like a band on the screen is called spectrum. Okay, so here you can see 1, 2, 3, 4, 5, 6, 7. Violet, indigo, blue, green, yellow, orange, red, Vibgyor. Violet, indigo, blue, green, yellow, orange, red. Okay, Vibgyor. So this is a Vibgyor. Violet, indigo, blue, green, yellow, orange, red. Okay. So when light ray passes through the prism, split into 7 colors. Those 7 colors you can see 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Those 7 colors will form like a band on the screen. That is called spectrum. Understood? So now recombination of spectrum of white light. So you can see. So I'm taking this. So actually Newton sent the white light through prism. So he split this white light into 7 colors. Further, he want to split the colors. So he placed a normal prism like this. So he placed like this. He couldn't get anything. So what he did? So he placed the inverted position of the prism. Like this. So here you can take this thing. So incident ray. So after that you are taking like this. Okay, again those colors will form. Then those colors will meet at one point and comes out as a white light. So here source, source white light, source white light, okay, white light here, and this the prism 1, and coming to prism 2, prism 2, prism 2, and this the screen, that is on screen will get white light, on screen will get white light. So recombination of spectrum of white light, this is the recombination of spectrum of white light, spectrum of white light, recombination of spectrum of white light. I hope it is very clear. Understood or not? Yes. So next one, rainbow formation by water droplet. So if you are taking the water drop here like this, okay, so I am taking like this. White light passes, split into 7 colors. So those 7 colors will comes out here. Then so here violet and red. So bottom is violet. So violet deviate the most, red deviate the least. Red has longer wavelength, it travels long distance. And here you can see this is the violet and red, and here also violet and red. Understood? So rainbow formation by water drop. So here what is the phenomena involved in the formation of rainbow? Refraction, second one dispersion, and the third one is total internal reflection. Sorry, internal reflection only. Internal reflection. Understood? So that's enough. Check once here. So you can see if the light ray passes through that, split into 7 colors. So those 7 colors will form like a band. Here 2 points. One is dispersion. Second one is spectrum. Okay, dispersion and spectrum. And coming to here, recombination of spectrum of white light. So this portion is recombination of spectrum of white light. This portion is so splitting of white light into 7 colors when it passes through the prism. Okay, so now you can see here recombination of spectrum of white light when it is passing through the prism, split into 7 colors. Those 7 colors comes out as white light. So this is the recombination of spectrum of white light, and here you can see when light ray passes, so refraction, dispersion, and internal reflection takes place. So this is about rainbow formation, and we will discuss about one more, that is okay. So now you can see here so now we will discuss about atmospheric refraction. Atmospheric refraction is nothing but refraction takes place by the atmosphere. Refraction takes place by the atmosphere is called atmospheric refraction. Okay, so best example. So your friend is standing here one side. So fire is in middle. Another side, one more friend is standing. So A, B. So okay. So friend A is seeing friend B through fire. Then what happens? The friend B image appears so somewhat wavering. Okay. So flickering, like fluctuating. Why? Because of refraction. So refraction is taking place in atmosphere. So the by the atmosphere refraction takes place. Okay, so that is called atmospheric refraction. So that is in a small scale. Coming to large scale, so from stars light rays are coming, right? From stars light rays are coming, keep on it's coming. So keep on refraction takes place. There are so many refractions here in the atmosphere. So everywhere same environment will not be there, right? So one it will be hotter, one it will be colder, like that it will be. So when light ray passes, okay, when light ray is moving in atmosphere, so many times refraction takes place by reaching to us. So the star appears twinkling. Star appears twinkling, but because the star position there only, because of refraction of light by reaching to us, it appears to be twinkling. Okay, and now you can see here. Now you can see here. So that is about twinkling of stars. Next one, atmospheric refraction. This is the Earth, and atmosphere. This is Earth atmosphere. Earth atmosphere. Okay. So here this the origin. This is the origin. So I am taking here is the sun. Sun here. Okay, so I'm standing, person is standing here. So when light ray is entering from Earth atmosphere, refraction of light takes place. So refraction by the atmosphere, then you can observe. So here is sun appearing. This apparent position of the sun apparent position. So here dotted line. Okay, the sun appears above its origin. Understood? So here is the actual position of the sun, that is apparent position of the sun. This apparent position of the sun. Apparent position of the sun. Apparent position of the sun. And coming to here, actual position of the sun. Actual position of the sun. Actual position of the sun. Understood? So this actual position, this apparent position, due to atmosphere, refraction of light takes place. So related to position, it is atmospheric refraction. Related to colors, the scattering of, so related to colors is scattering of light. What is scattering of light? Re-emission of light in all directions with a different intensity. Okay, so and even one more also during morning time, evening time. So sun appears red color, reddish, due to scattering of light only. Okay, whenever light released from the sun, so due to atmosphere, so light will scatter in all directions. Only red light travels long distance. It has longer wavelength. Okay, so that is one point. And coming to the one more point, advanced sunrise and delayed sunset also. 2 minutes advance and 2 minutes delay also, due to atmospheric refraction. Okay, so because of the atmospheric refraction, so actually sun still didn't rise. Okay, so sunrise. So but it appears here. Okay, so even we didn't see the sun here, but yeah, sun is here itself. Only. So it didn't even rise. Okay, so to this position, but it appears here. Due to atmospheric refraction, the sun appears here. That is apparent position of the sun. So how much time? Before 2 minutes. Before 2 minutes only, the sun appears. Above the origin. This is the origin. So the sun appears here. Origin. So above the origin, the sun appears. Understood? That is the upper end position. Upper end position. Upper end position of the sun. Okay, na? So before 2 minutes. After that, even sunset still it appears. Still it appears. How much time? 2 minutes. Okay. So 2 minutes early rise and 2 minutes delayed sunset. That is, so advanced sunrise and delayed sunset. So due to atmospheric refraction. And coming to the, so as I mentioned, during morning time and evening time it appears reddish color. Okay. So reddish color. That is due to scattering of light. So what is the scattering of light? The re-emission of light in all directions with a different intensity. The re-emission of light. Okay. So I'll explain, just check once. I'll explain so you can check. Here I'm saying, so this is the light which is incidenting on the particle. This is the particle. This is the particle. Okay, this is the particle. When light is incidenting on the particle, if you are taking the wavelength, it is, so this is the wavelength. This is the wavelength, the distance between two consecutive crests. This is a crest, crest, trough, trough, crest, crest. So the distance between two consecutive crests or two consecutive trough is called wavelength. The distance between two consecutive crests or two consecutive trough is called wavelength. Understood, Anna? Therefore, if the light ray is incidenting on it, this is the light ray. The light ray which is incidenting on it, that wavelength is comparable to the particle size, like this particle size. Then that particle will absorb the light. Then particle will absorb the light and re-emit in all directions with a different intensity. So that is called scattering of light. Re-emission. So because already light is coming, right? So after incidenting, if wavelength is comparable to the size of the particle, okay, so it is approximately equal or less than equal, like that. Okay, so then the time the particle will absorb the light, then re-emit in all directions with different intensity. Understood? That is a scattering of light. So sky appears blue color. Okay, sky appears blue color. So shorter wavelength scatters the most. When light releases, the particle present in the atmosphere scatters the blue light the most. That is the reason it appears blue color. So and even deep sea also it appears blue color due to scattering of light. Due to scattering of light, sir. Okay, sir. In the morning and evening you said okay. In the remaining time also it appears blue. What about noon time? It appears white because whenever light ray releases, due to scattering of light, so the particle present over there, so scatter the light equal in all directions. Okay, so that particle will scatter the light equally in all directions. So due to scattering of light, it appears white color. Due to scattering of light, it appears white color. I hope it is very clear. That's enough. So that is about scattering of light. And coming to the Tyndall effect. So Tyndall effect is nothing but, so scattering of light takes place by the colloidal particles. The phenomena of scattering of light by the colloidal particles is known as Tyndall effect. So you can see early morning if you open the windows, a parallel beam of light falls on the ground. So you can able to see the dust particles flying over there, right? So we can able to observe those dust particles flying in the parallel beam of light. Okay, and when you are moving on the road, so in midday, like that you can in the middle of the trees a narrow beam of light falls on that, we can able to see the dust particles are flying over there. Okay, this is all due to Tyndall effect. Okay, so I hope we covered all the points. So right from where? Right from human eye parts and function, myopia, hypermetropia, presbyopia, cataract, astigmatism, and after that light ray passes through the prism, split into 7 color, dispersion and spectrum, recombination of spectrum of white light, rainbow formation. After that scattering of light. After that atmospheric refraction. After that Tyndall effect. So as I mentioned, all the points we discussed. Thank you so much for joining and attending and listening my class. So this is the class 4. So already, so I made 3 classes. So related to light reflection part, and based on problems, light refraction part, and after that, so I did this video. This is the class 4, okay, fourth class. So just check once. Check. I'm uploading in the playlist. Target physics 25 by 25. Okay. Thank you so much. We'll see you in the next class. Thank you. Thank you.